Alright, welcome back. We're going to be continuing with the ACJC H2 Math paper from 2021. Yesterday I did questions 1 through 6, so today we're going to do questions 7 through 11. So question 7 seems to be APGP application question. So let's have a look at the context. Mr. Chan has a savings account, 3.2% interest per year. On the last day, that's when you pay the interest. You increase it by 3.2%. He also invests 8,000 at the first day of every year. Okay? So how much does he earn at the end of n years, counting the interest? Okay, so let's see. So year 1. So what is year 1? So on 1st January of 2020, which is the first day, he'll put in the 8,000, right? Then at the 31st December, he will get the 3.2% interest. So 1 times 1.032, which is 8256. Okay. What about the second year? You'll take the 8256 and then you'll add in another $8,000. Then you multiply this by 1032 or 1.032. So how can you rewrite this? Here you'll get another 8256. Here you'll get 8256 times this again, which is 8,000 times 1.032 squared actually. So I can write this as 8,000 times 1 plus 1.032. Actually no, 8256 times 1 plus 1.032, because the idea here is that this will become 8256. This is 8256 already, so I can multiply this by 1.032. Year 3, I can do the same thing. I will actually get 8256 1 plus 1.032 plus 1.032 squared, because the idea is I'm going to add 8,000 then pay the 1.032 at the end. So that 8,000 times 1.032 will give me the 1, the new 1 and the 8256. Then everything else will go up by 1 power. So this will continue until the end of your n, which you will see that it's 8256 1 plus 1.032 plus 1.032 squared, and this goes on until the end here. If I can fit it in the screen. Okay, and this is a GP, of course, so this is 8256. You can do the 1 minus r power n divided by 1 minus r. I'll actually write it the other way around. I'll write it as 1.032 n minus 1 divided by 1.032 minus 1. Okay, same thing. And then you just put the constants together. And if I did this correctly, this will be the 258,000. So that would be the 258,000 1.032 power n minus 1. Okay, so that will be question 7, part 1. So we go to part 2. We'll keep this in mind because I will need it. Anyway, it's on the left hand side of the screen because it was on the question paper. For 7 part 2, after 10 years, Mr. Chan stopped investing in the savings account. He does not withdraw. He will still continue to get 1.5% interest. Alright. By the end of which year will he first get more than $35,000 from the day that started the saving account? This is total interest, so we do not count the amount that he put in. The amount that he put in is 8,000 times 10. So amount invested is just 8,000 times 10, which is of course 80,000. So we calculate how much Mr. Chan has after 10 years. Okay, which is 258,000, 1.032 to the power of 10 minus 1. Oops. Oh, okay. So this is 258,000, 1.032 power 10 minus 1, which is 955,221.8995. Okay. I'm using my scientific calculator for this, so your graphic calculator might give a few more digits. Okay. Oh, sorry, I pressed an extra 0, so it should be 95.521. 9552, yeah. Should be this, yeah. Okay, so you have this much. This is how much Mr. Chan has. So this is going to increase by 1.5%, but you need to remove the 80,000 so that you get 35,000. Okay, so let K be the amount Mr. Chan has after K years from, so after 10 years, so he invested on 2020. After 10 years, his last one will be on 2029. K years from 2029. So that means that this 1.5% will be start to pay from 2030 onwards. Okay. So we need to solve first more than $35,000. So we take 95522.18995 times 1.015 to the kth power minus 80,000, which is the amount that he invested, so it's not counted in interest, is greater than 35,000, which you can solve for 1.015k to be greater than something. You'll get this to be 1.2039. Oops. And if you solve this inequality, which you will use log, or you can use your graphing calculator if you want, you will get k more than 12.5, 3SF. Okay, least k equals to 13, so it will be 13 years after 2029, which is year 2042. Okay, so that will be part 2. Finally, Mr. Chan starts receiving a monthly payout from 20 years from the savings account if he did not withdraw. The monthly payout is $850 for the first year, then D dollars more than the monthly payout the previous year. So this is sort of an AP. The total payout to Mr. Chan at the end of 20 complete years is 352,000. So let's see, payout in year 1 is 850 times 12, which is 10,200. Payout in year 2, now you increase by D, 850 plus D times 12 equals to 10,200 plus 12D. So you'll see that the payout total after 20 years will be, the 10,200 will always stay together, so times 20, plus, then you see that you will get 12, then this D will add up, D plus 2D plus 3D plus dot 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 plus 19D, okay, which is 204,000 plus, then you can use the AP formula to solve this, which is 2280D, and this is equals to 352,000. Oh, it's not 352,000, it's 352,200. Okay, sorry about that. Okay, then you can figure out what D is, and you will actually get D is 65 exactly. So 11th year is going to be 850 plus 10D. So that will be $1,500. Okay, so that is that's your M value also lah. M is 1,500. Alright, cool. Question 8 is an integration question. By substituting x equals to cosine theta, find this integral. Okay, so integrate x cubed divided by root 1 minus x squared dx. So I have x equals cosine theta, dx d theta equals to negative sine theta. So this is so I can just substitute this directly in. So I'm going to get cosine cubed theta divided by 1 minus cosine square. Square root of that will just be sine theta. Okay. Then this is times negative sine theta d theta. So this is the integral of negative cosine cubed theta d theta. Okay. How do I find this integral? Whenever you have a power of a trigo, the standard approach is to consider sine. So what I can do is I can actually write this as cosine theta 1 minus sine square theta d theta, because this is cosine square times cosine itself, and then I can get out this minus also. So this becomes integral of sine square theta. I'll write it as cosine theta sine square theta minus cosine theta d theta. Okay. Yes. Okay. So this is f prime x f power x fx power n. Sorry. This is sine square. Cosine is the derivative. So this is going to be sine cube of theta divided by 3 minus sine theta itself. Then we're going to change this back to terms of x. Let me make this clearer that this is cube. Okay, so let's just draw a right angled triangle so that we know what does this change to. So this is theta. Cosine theta is adjacent divided by hypotenuse. So let's call this x, let's call this 1. Then this is square root of 1 minus x squared, right? So sine theta is square root of minus x squared. So 1 minus x squared to the 3/2 power divided by 3 minus square root 1 minus x squared plus c. Okay? Okay. For second part is just a simple verify question. So y equals to x cubed divided by 1 minus x squared, square root of this rather. When x equals to half, what is y? This is 1 over 8 divided by square root 1 minus 1 over 4, which is 1 over 8 times 2 over root 3. So 1 over 4 root 3. If you want, you can write this as root 3 over 12. Y equals to 1 over square root 49 minus 4x squared equals to, when x equals to half, y equals to 1 divided by 49 minus 1. This is 1 over root 48, which is, once again, this is root 48, which is 16 times 3, so this is 1 divided by 4 root 3. So that implies that also. So it's the same thing. Okay. Okay. For this last part, we're going to find the area of the region bounded by the two curves, and we're going to find that area exactly. So you can use your graphing calculator to sketch the two curves if you need to. This is what I got on Desmos. So we need to find the area bounded by the two curves and the y-axis, which is going to be this area. It's going to be the area under the blue but above the red, essentially. You could consider a rectangle and integrate. No, it's not a rectangle, sorry. It looks rectangular, but it's not. If I scale the graph, you'll see it's actually curved. So what you could do to find this area is to consider the area under this curve minus the area under this, the area under the blue curve minus the area under the red curve. And that will give you, actually, yeah, that will already give you the answer, right? Okay, so let's go on to find the area. So for this question, they didn't say that you cannot use a graphing calculator, so I would assume that the best way to go about finding how to get that area is to, use the graphing calculator to sketch out the curve and see what you actually need to integrate. So in this case, you're going to find the exact value of the integral from 0 to 1 of x cubed divided by root 1 minus x squared, okay, minus the, it's the other way around. It's 1 over square root 49 minus 4x squared minus x cubed divided by square root 1 minus x squared dx. Okay. So I can already evaluate this part. So it comes to finding integral 0 to 1 of 1 over square root. So this is an a square minus x squared thing, but you need to remember that the coefficient of x squared must be 1 before you can apply the formula. So what I'm going to do is I'm going to factor out the 2. So I can put the 2 on the outside, and this becomes 49 over 4 minus x squared. And if you want, you can write this as 7 over 2 squared minus x squared. Alright? Because there's a formula for a squared minus x squared. Minus, okay, you can write down the integral for this, which is that thing. 1 minus x squared to the 3 over 2 power, divide by 3, minus square root 1 minus x squared. We're going to go from 0 to half. And then on the left hand side, we'll work out what this is. Now, square root of a square minus x square, I believe this is associated with sine inverse, if I'm not wrong. So this is let's see, so this is a square. So I think the formula is this is sine inverse x over 702. So sine inverse 2x over 7. This is 0 to half. Then we're going to figure out what this is. This is if I put in half, you will get 3 over 4 to raise to the 3 half power, which is root 3 over 2 cubed, which is 3 root 3 divided by 8. So it's root 3 divided by 8 minus root 3 over 2. And then when this is 0, this is just 1/3 plus 1 lah. Okay. Okay. So there's no nice answer for sine inverse of x over sine inverse of x of 1 over 7. Sorry. So you just leave it as half sine inverse 1 over 7 minus, okay, and then you figure out what this is. This is three root 3 over 8. Let me just bracket this to make it clear. They're separate. Plus 3 root 3 over 8. And then minus 2/3. Yeah. Yeah. This looks good. Okay. Question 9 is complex numbers. Show that this cubic polynomial can be reduced to this by the substitution x equals to y minus p over 3. Okay. So we have x cubed plus px squared plus p square x plus q. Let x equals to y minus p over 3. The motivation behind choosing p over 3 is due to binomial theorem expansion, I think, because it's the Pascal's triangle is 1, 3, 3, 1. So let's do it. So this is just applying binomial theorem, which is from secondary school. So you will get y cubed minus, this should be py squared plus p squared over 3y minus p cubed over 27 plus py squared minus 2yp squared, yeah, 2p squared y over 3, then plus p squared over 27, then plus p squared y minus p cubed over 3. Actually, no, this p cubed, sorry. Everything should have a p cube in it somewhere. Then plus cube. Okay. So the point is to make sure that there's no y squared term. And in fact, you will see that there is indeed no y squared term because this and that will cancel. What else is eliminated? This and that also cancel, which is nice. No, wait. Why is this p cubed over 27? This is p cubed over 9. Right? Yeah. I don't know why I wrote 27. Sorry. Okay. So this doesn't cancel. P cubed over 27. Okay, this is 3 over 27. So this is 2 over 27. Minus 9 over 27. So this is minus 7 over 27. So this is y cubed plus, if you get the p squared terms, you get the y terms rather, you will see that it's actually minus p squared over 3 plus p squared. So it's 2p squared over 3 minus 5p cubed over 27 plus q. Alright? No, not 5, sorry. I think it's 7. Because it was 2 minus 9, yeah, 7, sorry. Okay. So your alpha is q minus 7p cubed divided by 27. Alright? Given that minus 3i is a root, find the other two roots. So you can verify that it's a root if you want. So let's do part 2. You can verify that it's a root if you want, but I won't do that. Y cubed plus 6y minus 9i equals to 0. Now, the coefficients are not real numbers. 9i is a complex, so you cannot use the conjugate root theorem. What you do instead is you will factorize it using the comparing coefficients method. So we know that 3i is a root, so y plus 3i, we write this in the form y squared plus by plus minus 3 equals to 0. So we suppose that there's some kind of factorization. We choose minus 3 since 3i times negative 3 is negative 9i, and y times y squared is y cubed. So coefficient of y is 3bi minus 3, which is 6. So b itself is minus 3i. And I think you can check y squared also. This is 3i, so it has to be minus 3i since the coefficient of y squared is 0. That actually might be slightly easier. Okay. So now I have to solve y squared minus 3iy minus 3 equals to 0. And you can apply the standard quadratic formula to this. It works even for complex number kind of a coefficient. It will still work. So y is 3i plus or minus the square root of 3i squared is negative 9 minus 4ac. So 4ac is 12. So this is the square root of 3 all over 2. So y equals to that's it. Y is in the form a plus bi, right? So root 3 over 2 plus 3 over 2i, or y equals to negative root 3 over 2 plus 3 over 2i. Okay? Yeah. Hence, find the exact roots of this equation. Why am I labeling this question 8? This is question 9. Okay. Hence, find the exact roots of this equation. X cubed plus 3x squared plus 9x plus 7 minus 9i equals to 0. It says hence, so we probably have to make use of the previous parts. Let's look at what we have earlier. X cubed plus px squared plus p squared x plus q equals to 0. So what do you notice? Actually, I can choose p equals to 3, right? And this will give me x cubed plus 9x squared. Sorry, x cubed plus 3x squared plus 9x. Then the q is 7 minus 9i. So by observation, p equals to 3, q equals to 7 minus 9i. So this, let x equals to y minus p over 3 equals to y minus 1. So it reduces to, so this will be reduced to, based on the earlier part, y cubed plus 2 over 3 y plus alpha. Alpha was q minus 7 p cubed over 27. So q minus, so 7 minus 9i minus, actually no, it's not 2/3, sorry. P squared is 9, so this is 6. Okay. Minus 9i, 7 minus 9i, then minus 7p cubed over 27, which is just 7 itself. So this is y cubed plus 6y, just minus 9i. And we actually solved this earlier. So actually we just replace, y by x plus 1. Okay, so therefore x, you will just take whatever the y values were and you will subtract 1. Okay, so it's root 3 over 2 minus 1. So root 3 over 2 minus 1 plus 3 over 2i, or x equals to negative root 3 over 2 minus 1 plus 3 over 2i. Okay? Yeah. I think it's really cool using this substitution. This substitution has been known for a very long time, and it's been used to solve cubic equations even before complex numbers were known. Part B, okay, this is using the polar form of complex numbers. So we have z equals to e to the I theta. So the modulus is 1. I'm not sure if we need that here. So I have 1 plus z squared plus dot 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 plus z power n minus 1. Okay. Of course, this is a geometric series, so you can do it. You can do this zn. You can just write down the geometric series z power n minus 1 divided by z minus 1. But how do I get out the signs? There's a sine n over 2 and a sine theta over 2. How can I get that out? Well, you probably need to play around with the properties. So here is a suggestion. Let's write down in the polar form first. So this is e to the ni theta minus 1 divided by e to the I theta minus 1. What I'm going to do is I'm actually going to multiply. I'm going to do something a bit unexpected to some of you. E to the power of ni theta minus 1. And I want to multiply this by e to the negative I theta over 2. I'm going to do the same at the bottom so that I get e to the I theta minus 1 times e to the negative I theta over 2. When I do this, I'm multiplying, this 2 will cancel out, so it's still the same thing, right? But if I expand this, this is e to the n minus half. So this, I can actually write this as a 2n minus 1 divided by 2 I theta minus e to the negative I theta over 2 divided by e to the negative I theta over 2 minus e to the I theta over 2. No, sorry, this is I theta over 2 positive. The one on the next side is the negative one. Okay, negative I theta divided by 2. Alright, so how does this help us? Well, I know that actually this form is something that I know, right? E to the I theta over 2 minus e to the negative I theta over 2. This is actually 2i sine theta over 2i sine theta over 2, right? Because it's the difference of two complex numbers with which they are conjugates. So it's 2. So you will get 2i times the imaginary part. The imaginary part is sine theta over 2. So this is 2i sine theta over 2. What about the top part? I'm actually going to factor out something from the top. Here's how I'm going to write it. I'm going to write this as e to the power n minus 1 divided by 2 I theta. I think so, because then I will get n over 2, right? So let's see what happens if I do this. So this will give me e to the ni theta divided by 2 minus 1. So this is going to be minus 1. So what multiplied by n minus 1 divided by 2 gives me negative 1. Oh wait, yeah, it turns out that this is quite hard. Does minus ni theta work? Let's see. This is going to give me n minus n, so this is n minus half. Yes. Okay, so it's a tough question actually, but e to the I theta is actually z, so this is z n minus 1 divided by 2 times 2i sine n theta over 2 divided by 2i sine theta over 2. I would not expect many students to get this during exam. It's only 3 marks, so don't worry if you don't get it. The two i's cancel out, so you get z to the power of n minus 1 divided by 2 sine n theta over 2 divide by sine theta over 2. Okay, cool. That's question 10. Question 9 rather. The Gompertz differential equation, okay. This is a biology kind of context. Population growth is nothing new to us. For those of us who did many differential equation question practices, you know that there are many models. The common one I see in exams all the time is the logistic growth, the Verhoeven one, which is the Gompertz curve is very similar, slightly different though. So we have this differential equation that we're going to refer to. dv dt equals to av ln of k over v. Okay. As v tends to k, what is the behavior of dv dt? K over v tends to 1. So ln k over v tends to 0. Therefore, dv dt tends to 0 as well. Okay. The idea is that v is going to be less than k. If v is less than k, then this will be more than 1, then dv dt. So dv dt decreases to 0. So essentially, k is you might actually be able to notice that k will be a carrying capacity. And we'll address this in the later part of the question. Then part 2. By substituting u equals to ln k over v, solve the differential equation. Okay. dv dt equals to av ln k over v. U equals to ln k over v. What is du dt? We'll differentiate with both sides with respect to t. Now, the k is irrelevant because it's constant, so it's just negative ln v, right? So I differentiate, I'll get 1 over v. The derivative... No, sorry. I will get negative 1 over v times dv dt. So I can actually multiply this. So I get negative 1 over v dv dt, which is, I'll divide negative on the other side. So this is minus a ln k over v. And of course, this part is u. And this part is du dt. So du dt is equals to minus au. Alright? So that is your differential equation. This is a very trivial differential equation to solve in terms of u. So it's a separable equation. So minus 1 over au. Integrate this. Du equals to integrate 1 dt. You get minus 1 over a ln mod u equals to t plus c. So ln mod u equals to minus AT minus AC. Mod u equals to E minus AT minus AC. U itself is going to be AE minus AT, where A is equals to plus minus E to the negative AC. Okay, because I'm going to get rid of the mod by doing that. Okay, but U is ln K over V, so ln K over V equals to AE minus AT. I'm going to make V the subject. So ln V equals to ln K minus AE minus AT. And then V is e to the power of this. So you will get K E minus AE minus AT. Yeah, there you go. What happens to V as t tends to infinity? Part 3. As t tends to infinity, E minus AT tends to 0, right? Because A is a constant and we assume that it's small relative to t. So you will get e power 0, everything is going to be 0, so you will get V tends to k itself. Okay? So what is k? K is the... Well, I say carrying capacity, but it's not population growth, it's more of a lung cancer growth. So we can say that this is the maximum volume of the tumor. Okay? Yeah. For the rest of the question, you may assume that A equals 0.01 and K equals 8,000. Find the size of the tumor after 100 days. Okay, so we have V equals to 8,000 minus, e to the power of negative AE to the power of negative 0.01t. Then we are given that the early lung tumor was discovered with volume 100. So this is when t equals to 0, V equals to 8,000 E minus A, which is 100. So this is E to the power of negative A is ln 1 over 80. So A itself is ln 80. Okay. When t equals to 100, you can go ahead and find out. V equals to 8,000 e to the minus ln 80 e to the negative 1 power. Then you can go find what V is. You will find that this is nearest mm, right? 1596 mm cube. Okay? Yeah. And then finally, for sketching the graph of V against t, I believe that we can probably do this using our GC. In this case, I'll use decimals, but in your exam, of course, you'll use the GC. Now, when you sketch using GC, you just want to get the shape. So we'll sketch e to the minus ln 80 e to the negative 0.01x, right? Okay. So we just want the general shape. So let's see if I can get it. Okay, if you use 8,000, you will get a really stretched out graph. So here's the graph when you get. So to get the general shape, you can kind of do it like that. It's already going to raise up very high. So you want the general shape, I would say you need to probably adjust your scaling on the GC. So this question is also testing your GC skills. So you probably need to increase the scale of your X by a lot. And you will see that there's an asymptote here of 0. And then it will also approach the asymptote of whatever K is. In this case I put 80, but it should be 8,000. So the curve, it will overall look, if you close in the curve, it will look something like that. You'll see that it's a bit tighter towards the left side than it is the right side. It's an unbalanced sigmoid curve. It's not like the Verhoeven sigmoid curve, which is balanced. So it's slightly different, but it still works. Once again, this is just the shape. The actual value will be 8,000, so you will need to do something like that. And you will need to state your asymptotes, the vertical intercept. You're only going to sketch the part where t is greater than 0, so you start at 100 and then sketch everything from there. Alright, that'll be all for this question. The last question under the other real world context is vector geometry. So we have Mr. Neo, he wanted to build his shed. Okay. So we have these planes, they are parallel to the horizontal plane A, B, C, D, E, F, G, H. So those are like the roof and the base, right? Okay. The triangles APD and BQC are congruent, isosceles, so they are parallel. So it's like a prism basically. The lengths of the pillars are the same height. So this is like a cuboid. ABQP has this Cartesian equation, and the point P has this position vector. Okay, explain why this line CDPQ. So we have ABQP, which is the one on the left side. What they're asking is, what is the equation of this one? And we are given that why is it perpendicular to this? Well, actually it's quite simple. It's because if you notice, right, one is a reflection in the line PQ. So I will just write CDPQ is a reflection of ABQP in the line PQ. Yeah. So the perpendicular vector and PQ itself is parallel to the Z. No, rather is parallel to the XY plane. Okay. The perpendicular vector is so you will change your negative x and negative y to positive, but the z itself will stay the same. So you get 2, 1, and 3. So we're given that P lies on the plane. So CDPQ has the R dot 213 equals to, you pick any point on the plane, which I'll pick P. We are given the position vector 424 dot 213. And you can multiply this out. This is 8 plus 3 plus 12, which is 23. So that's how you get the 2x plus 3y plus 3z equals to, yeah. Let me just, 4, 2, 4. Something's weird. Why is this, wait, this is 23. Did I do something wrong? Yeah. Oh, no, I just cannot. I just thought 2 times 1 equals 3 for some reason. Okay. 22, yeah, there you go. Okay. 11 part 2. Find the angle the roof ABQP makes with the horizontal plane. Okay, angle between two planes. So this is actually very simple because one of the planes is literally the XY plane. So normal vector, so the standard approach is to let the angle be theta. So both are planes, so theta is actually sine inverse. So I'm going to take the mod of, so what I do is I take the two, no, not sine inverse, cosine inverse. Because when they are the same type, they are cosine inverse. When it's a line and a plane, then you sine inverse. So you take the dot product of the two perpendicular, of the two vectors that you're considering, which is 2, 1, 3, dot 0, 0, 1. Then you divide by the modulus of the two vectors. Okay. And then this is 3 divided by square root of 14. Okay. Then you can go and find what theta is. When you do vector questions, your answer should always be in degrees, 1 decimal place. So 36.7 degrees, 1 dp. You can use radians and leave it in 3SF, but my school taught me that I'm also from ACJC, so we were taught to always leave it in degrees. Not sure if they will set radians, but generally try to put degrees. Find the vector equation of PQ. Find the coordinates of point Q given that PQ is 3 root 5 units. Okay. So PQ is actually the intersection of the two planes, right? So what I'm going to do is I'm going to solve them in Cartesian equations. So 11 part 3. negative 2x plus y plus 3, no, this is negative y, plus 3z equals to 2, and 2x plus y plus 3z equals 22. Okay, so you can solve these two equations simultaneously to find the equation of the line in the Cartesian form. You will get z equals to 4. And you have 2x plus y being equals to 10, right? Which implies that y is 10 minus 2x. No. Yes. Okay. So PQ, you have the equation y equals to 10 minus 2x and z equals to 4. Let x equals to lambda. Then y is just 10 minus 2 lambda, right? So that you get a vector equation. You get r equals to lambda 10 minus 2 lambda and 4. Then you get out the fixed point. This is 0, 10, 4 plus lambda 1 minus 2, 0. Okay, then lambda is some real number. Yeah. And of course this is non-unique, so you can find this in any other way. There's going to be a lot of possible ways to get this thing. Okay. We're given that PQ is 3 root 5. We know P is 4, 2, 4, right? So PQ is OQ minus OP. which is, we know that OQ lies on the vector equation of PQ, so you get 0, 10, 4 plus lambda 1 minus 2, 0 minus 4 to 4 for some lambda. Okay, and then of course this is lambda minus 4 minus 2 lambda plus 6. No, 8, sorry. 8 minus 2 lambda. And that's it. 0. Okay. Mod PQ squared. I'm going to consider the square of the modulus so that I don't need the square root. And this is going to give me lambda minus 4 squared plus 8 minus 2 lambda squared. And this is actually the same thing as lambda minus 4 times 4. The lambda minus 4 squared times 4. So this is 5 lambda minus 4 squared, which is 3 root 5 squared, which is it's 45. Okay, so that's to say lambda minus 4 squared equals to 9. Then you can go ahead and find what the values of lambda are. Lambda is going to be 4 plus minus 3. This will give me lambda equals to 7 or lambda equals to 1. From here I can go and find my OQ. So OQ equals to so I use this one, I'll get OQ is OP plus PQ, so I'll get 3 minus 6. No. Yes, minus 6. Then you add PQ. So you'll get 7 minus 4. 4. Or OQ equals to, you put 1 in, you will get 1, you get negative 3, you get 1, 4, no, you get 8, sorry, you get 1, 8, and then 4, I think. Yeah. Okay. But clearly only one of these can be possible, so which one should it be? Actually, the diagram is what gives you the hint. I'm going to reject this one. From diagram, you can see the top-down view that they give you is a hint actually. That the y coordinate of Q is going to be greater than the y coordinate of P. And the y coordinate of P is actually 2. So therefore your coordinates of Q will be 1, 8, 4. Nice. Okay. When the shed was completed, Mr. Neo discovered a hole. Light shines perpendicular onto ABQP. The light passes through the hole and hits the ground at the point of 360. Find the coordinates of the hole. Okay. So we're going to find the equation of a perpendicular line. Now we already know what is the equation, or rather we already know what is the direction vector. Let L be the light ray. L will be R equals to, we pick the fixed point, 360 is the point we're given, plus mu, and the direction vector we already know is -2, -1, 3. Mu is a real number. Okay. We also know that ABQP. We also know that there's a plane equation for this, which is just R dot -2 y -1 and 3. This is equals to 2. So we use these two equations together, we'll get 3 minus 2 mu, 6 minus mu, 3 mu, dot -2 -1 3. Then we can work out what this is. This is -6 plus 4 mu, -6 plus mu, plus 9 mu, which is 14 mu minus 12 equals to 2. So mu equals to 1. Then you can find the coordinates of the hole, which lies on L. So the coordinates of the hole will be 1, 5, 1. Or no, actually 1, 5, 3. Sorry. Yep. Okay, that's it for ACJC H2 Math Paper 1. Overall, I find that this paper is a pretty easy paper. So hopefully you guys found it okay, manageable also. I was from ACJC, so I took the 2022 prelims, and I think they're harder than this. Slightly harder. But the vectors question was still okay for my prelim. If I get the question paper, I'll try to go through the 2022 prelim as well. If not, the next paper I'll go through will be an A-Math paper, because I have a request from my friends back at ACS Barker, my secondary school. Okay, and once I do that, I'll go back to another A-level paper. Okay, so that will be all for now. I'll see you all next time. Thanks so much for watching.